Hello, so in this video, what we're going to do is look at differentiating the hyperbolic sine function. So some people call it hyperbolic sine, some people kind of shorten it to sinh, or some people say shine. I'm just going to try and call it hyperbolic sine throughout this video and throughout the rest of the videos that I do on this differentiation. So yeah, I mean, if we define what we mean by hyperbolic sine, so, I mean, there's a couple of ways that we could do this. So we could define hyperbolic sine in terms of exponentials. So this would be the definition in terms of exponentials. I'll call this definition number one. Just make a title of definitions here. So yeah, so again, there's different ways you can define this hyperbolic sine function. You can also define it in terms of complex variables. So yeah, another definition of this hyperbolic sine function is negative I sine of I times x. So that's another way that you can also define what we mean by this sine, or sorry, this hyperbolic sine, sinh, or shine function. I'm also going to write out the definitions of cosh, or hyperbolic cosine. So definitions of shine, I'll just put that in the title up there. And then down here, I'm going to do the definitions of the hyperbolic cos function. And I think you'll see why I'm doing this when we actually do the differentiation. So definition one. So again, you can use this this exponential definition for the cosh as well. So this would be a half of e to the x plus e to the negative x this time, instead of the negative that we've got up there with the hyperbolic sine definition. Or you could also define it again in terms of complex variables. So this would be this time cos of ix. So that's another way that you can again define these hyperbolic functions. Okay, great. Yeah, so we're going to use these definitions, well, both of these definitions up there, to differentiate hyperbolic sine. And yeah, these definitions of the hyperbolic cos function may come in handy. So yes, if we start by doing what we want to do then in this video, which is differentiate the hyperbolic sine function. So if we use definition number one, so using definition one, so yeah, so this is just the same as a half, or differentiating a half of e to the x minus e to the negative x. I'm just going to take that half outside the differentiation just because it's a constant. So e to the x negative e to the negative x. Okay, so we can obviously differentiate the e to the x and the negative e to the minus x separately, since differentiation is a linear operator. So we can differentiate e to the x. Then we can take away the derivative of e to the negative x like that. Okay, so I mean, with this first part then, when we've got to differentiate this, it's just e to the x just here. So we know that when we differentiate e to the x, the exponential function, we get the exponential function. So we showed that in previous videos. So that's just e to the x. And then when we differentiate e to the negative x, so a bit of chain rule. So we differentiate the negative x in the power. So when we differentiate negative x with respect to x, that's just negative 1. So we bring the negative 1 to the front there, and we differentiate the e to the x with respect, e to the negative x with respect to negative x. And when you do that, you just get e to the negative x. Because again, when you differentiate the exponential function, you get the exponential function itself. So then we can just simplify the negatives. So we'll get half of e to the x, and then minus e to the negative x, so plus e to the negative x. Okay, so that's our final answer then. But if we actually just go back to this exponential definition for the hyperbolic cosine function. So that is exactly the same as this. And so this just equals cosh, or hyperbolic cosine of x. And so therefore then we can conclude that d by dx of sine, hyperbolic sine, put the x in there, is just hyperbolic cosine of x. Okay, so we've proved that using like the first definition. What I'm going to do now is use this second definition. So let me just put ticks by the first definitions. We've used that one to prove that when we differentiate hyperbolic sine, we get hyperbolic cos. I'm now going to use this definition number 2 to do the same thing. So using definition 2, so yeah, if we differentiate again hyperbolic sine of x, by definition, this is just exactly the same as differentiating negative I sine of ix. So if you're not familiar with complex variables, this I is just the square root of -1. So yeah, again, this is kind of a bit of chain rule, really. So what we're going to do is we've got this negative I constant, actually, so I'm just going to bring that out to the front because that is just a constant. So we want to differentiate this sine of ix. So again, a bit of chain rule. So you've got a function of a function, so sine of ix. So we want to differentiate the function inside the sine. So again, differentiate I times x, that's just the constant I. So you're going to get negative I times I, and then differentiate this sine of ix with respect to ix. Well, when we differentiate sine, we get cos. So that's going to be cos ix. And then again, we can simplify this a little bit. So negative I times negative I, I times I, if we just start with that bit there. So we know that I, by definition, is the square root of -1. So that means that I squared equals -1. So we've got negative -1 times cos ix. And -1 is just 1. So that's cos ix. And again, if we go back to our definition list, so cos ix is by definition the same as cosh, or hyperbolic cos of x. And so again, using the second definition, what we've just done there is once again shown that when you differentiate hyperbolic sine, you just get hyperbolic cos. And so that result is still true regardless of which two definitions you use to prove this.